What if the future of space travel didn't involve expensive rockets or years of preparation? Picture this. A colossal elevator stretching from Earth all the way into space, allowing us to send goods, people, and even energy into orbit at a fraction of the current cost. This isn't science fiction, it's a concept Japan is actively pursuing. With cutting-edge technology and innovative materials, Japan is working on making the impossible possible. If they succeed in building a space elevator, it would not only revolutionize how we explore space, but could also reshape the global economy, environmental practices, and our place in the universe. The world as we know it would change forever. Imagine a future where space travel isn't just for astronauts or the super wealthy, but as simple as taking an elevator ride. Picture a monumental structure extending from Earth all the way into space. A revolutionary idea that could change everything we know about reaching the stars. This is the concept of the space elevator, and Japan is leading the way to make it a reality. Once seen as pure science fiction, the space elevator is now becoming a tangible possibility thanks to Japan's expertise in advanced technology and engineering. The plan is to construct an enormous cable reaching the Earth to a station in geostationary orbit, allowing us to send cargo, people, and even energy into space without relying on traditional rockets. The potential impact of such a project is nothing short of extraordinary. It would dramatically lower the cost of space travel, unlock new industries, promote advancements in renewable energy, and make space more accessible than ever before. This could even lay the foundation for human colonies on the Moon or Mars. If Japan succeeds, the world will be forever changed. A space elevator could revolutionize how we interact with space and lead to a new chapter in human exploration and innovation. It's an ambitious mega project that could redefine our future. Number 1. Understanding the space elevator concept. A space elevator represents a revolutionary idea in space exploration, aiming to make space travel more affordable and accessible. At its core, this concept involves a massive cable or tether extending from the surface of the Earth to space, reaching a point called geostationary orbit, approximately 35,786 kilometers above the Earth's surface. The tether would be anchored to Earth and connected to a counterweight in space, maintaining the necessary tension to keep the elevator upright. This elevator would provide a means to transport goods, equipment, and people into space using climbers, specialized vehicles that would ascend the tether using electricity or lasers for power. Unlike rockets, which are costly and environmentally damaging, space elevators could significantly reduce the expense of space travel. This idea, initially proposed by Russian scientist Konstantin Tsiolkovsky in the late 19th century, has captivated the scientific community for over a century. By eliminating the need for rocket propulsion, the space elevator could change the dynamics of space exploration, offering a more sustainable and frequent method of sending satellites, cargo, and even human passengers into orbit. This could pave the way for new industries in space, such as asteroid mining or off-Earth manufacturing, and could even make space tourism a reality. With ongoing advancements in material science and engineering, the space elevator could soon transition from a science fiction vision to a practical reality. Japan, with its technological capabilities, is at the forefront of researching and developing the required technologies for this massive project. Number 2. Japan's contributions to space innovation. Japan is a recognized leader in technological innovation, particularly in the field of space exploration. Through its National Space Agency, JAXA, Japan has been involved in numerous pioneering space missions. These include satellite launches, lunar exploration, and significant contributions to the International Space Station. Japan has shown consistent expertise in robotics, automation, and material science, placing it at the forefront of emerging space technologies, including the development of a space elevator. The country's commitment to space exploration has allowed it to develop the necessary infrastructure and knowledge base to tackle ambitious projects. The Japanese aerospace industry, supported by both public and private sectors, has already demonstrated success in deep space exploration, such as the Hayabusa mission to collect asteroid samples and return them to Earth. These achievements highlight Japan's capacity to take on complex technological challenges and pave the way for future advancements in space exploration. In the case of the space elevator, Japan's private companies, like Obayashi Corporation, have become leaders in this field. They've proposed designs and strategies for building the elevator, focusing on the use of advanced materials and technologies. The country's cutting-edge research in carbon nanotubes and graphene plays a critical role in solving one of the most pressing challenges of constructing a space elevator, creating a cable strong enough to withstand the enormous forces involved. With a history of pushing the boundaries of technology, Japan is well positioned to bring the space elevator concept closer to reality. Number 3. Transforming space travel with a space elevator. Space travel has historically been prohibitively expensive and complex. Rockets, the primary means of getting into space today, are costly to build, operate, and fuel, and they generate significant environmental pollutants. A space elevator would change this dynamic by providing a cheaper, cleaner, and more sustainable method of reaching space. The elevator would replace rocket launches with a long, sturdy cable extending from Earth's surface to a station in geostationary orbit. Instead of launching a rocket, vehicles called climbers would ascend the cable, powered by electricity or lasers. This would drastically lower the cost of space travel, making it more feasible for regular cargo shipments, satellite launches, and even space tourism. In addition to making space exploration more affordable, a space elevator would also provide a greener alternative. Unlike rockets, which emit harmful gases and pollutants during launch, the space elevator would operate using renewable energy sources, significantly reducing the environmental impact of space missions. This would be a key advantage as global efforts to combat climate change intensify. Furthermore, the space elevator could enable frequent and routine missions to low Earth orbit, geostationary orbit, or beyond. This would open up new possibilities for space exploration, including lunar bases, Martian missions, and even asteroid mining. If successful, the space elevator could revolutionize space access, offering a new pathway for humanity's expansion into the cosmos and making the dream of interplanetary colonization more achievable. Number 4. Overcoming technological obstacles and building a space elevator. While the concept of a space elevator is captivating, it presents formidable engineering and technological challenges. The most significant hurdle lies in the need for materials that are incredibly strong, yet lightweight enough to support the immense weight of the tether, which would stretch over 35,000 kilometers from Earth to space. The tether must bear not only its own weight, but also the weight of the climbers, cargo, or any potential infrastructure along the way. Current materials, including steel and carbon fiber, are sufficient for the task. The strength-to-weight ratio required for a space elevator far exceeds what is achievable with these conventional materials. As a result, researchers are turning to more advanced substances such as carbon nanotubes and graphene, which have impressive strength properties but remain difficult and expensive to produce at the required scale. While these materials hold potential, their large-scale production remains a significant barrier. In addition to material challenges, the elevator's design needs to account for forces such as gravitational pull, centrifugal force due to Earth's rotation, and space weather conditions. The tether must remain stable even in the face of these forces and withstand the constant tension over its vast length. Space debris, which poses a threat to satellites and spacecraft, would also be a concern for the elevator, necessitating protective systems to prevent damage. Moreover, the technology required to build the climbers, which would carry cargo and passengers, must be both lightweight and highly efficient. These climbers would need to operate without conventional fuel and be powered instead by electricity or laser beams, adding another layer of complexity to the project. Despite these challenges, ongoing research in material science, robotics, and energy systems is gradually moving the space elevator closer to feasibility, though the road ahead will require years of innovation and global collaboration. Number 5. Exploring advanced materials for the space elevator. To build a space elevator, one of the key requirements is developing materials strong enough to handle the immense weight and stress placed on the tether. A suitable material must possess extreme tensile strength while remaining lightweight. Currently, no known material can meet this challenge, which is why cutting-edge research into advanced materials is so crucial to the success of the space elevator. Carbon nanotubes are among the most promising materials for this purpose. These cylindrical structures, composed of carbon atoms, exhibit incredible strength, many times stronger than steel, and are also very lightweight. However, producing carbon nanotubes in large quantities at a reasonable cost remains a major obstacle. Although they can be synthesized in small batches, scaling up production for the space elevator would require breakthroughs in manufacturing techniques. Another material that could play a key role in is graphene, a single layer of carbon atoms arranged in a two-dimensional lattice. Graphene is known for its strength, electrical conductivity, and lightness, making it an ideal candidate for building the space elevator's tether. However, like carbon nanotubes, graphene is expensive and difficult to mass produce. The researchers are working on ways to make graphene more commercially viable by improving the production processes. There are also other materials being explored, such as boron nitride nanotubes and diamond nanothreads, which also show great promise in terms of strength and lightness. Each of these materials offers unique properties that could help solve some of the space elevator's engineering challenges, particularly with regard to temperature stability and resistance to damage in the harsh conditions of space. Ultimately, developing these advanced materials at scale is critical to the realization of a space elevator. If researchers can overcome the current limitations of mass production, these materials could form the backbone of the elevator's structure, enabling the project to become a reality in the future. Number 6. The economic impacts of a space elevator. The economic impact of a space elevator would be transformative for both the space industry and the global economy as a whole. Space travel today is exorbitantly expensive, with the cost of launching a single rocket reaching tens of millions of dollars. A space elevator would drastically reduce these costs by offering a continuous, reliable, and reusable method for transporting goods and people into space. For businesses and governments, the ability to send satellites, scientific equipment, and supplies to space at a fraction of the current cost would open new avenues for space exploration, commercial ventures, and global communications. The development of a space elevator could make low Earth orbit accessible to more entities, leading to an increase in the number of satellite launches, space-based services, and scientific missions. This could result in a new economic sector centered around space-based industries, such as asteroid mining, manufacturing in zero gravity, and space tourism. Private companies could also benefit immensely from the space elevator's ability to deliver cargo more cheaply. With significantly lower launch costs, businesses in sectors such as telecommunications, environmental monitoring, and Earth observation would have increased access to the space they need to expand their operations. This could foster innovation, create new jobs, and stimulate economic growth in a variety of industries. The development and construction of the space elevator itself would also have profound economic benefits. The project would also require a massive workforce of engineers, researchers, and laborers, creating jobs across various sectors. Additionally, the need for new technologies, materials, and infrastructure could spur economic activity in fields like manufacturing, robotics, and energy production. Japan, as one of the nations leading the research and development of space elevators, stands to gain economically from this massive undertaking, potentially positioning itself as the hub for space elevator technology. Moreover, the long-term benefits would include an expanded economy with space as a central driver, possibly leading to the establishment of off-Earth industries that could contribute to economic prosperity on Earth. The space elevator would not just revolutionize space exploration, but could also be a key catalyst in the growth of the space economy, potentially changing the global economic landscape for generations to come. Number 7. Environmental benefits of a space elevator. A space elevator could have significant environmental benefits compared to traditional space travel. Currently, rocket launches are responsible for a large portion of the pollution generated by space missions. The combustion of rocket fuel releases carbon dioxide, black carbon, and other harmful pollutants into the atmosphere, contributing to climate change and damaging the environment. In contrast, the space elevator would offer a much cleaner alternative. Since it would be powered by electricity or laser beams, a space elevator would not produce emissions during operation. This could significantly reduce the carbon footprint of space exploration. Instead of relying on the chemical propellants that rockets burn, climbers would ascend the tether using renewable energy sources, which could make space travel more sustainable in the long run. Moreover, because the space elevator would reduce the need for frequent rocket launches, there would be fewer pollutants released into the atmosphere. Traditional rocket launches also generate significant noise pollution, affecting wildlife and human populations near launch sites. A space elevator would mitigate these impacts, offering a quieter and less disruptive method of getting into space. Beyond reducing emissions, the space elevator could have broader environmental implications for Earth. By enabling easier access to space, the elevator could facilitate the development of space-based technologies aimed at solving global environmental problems. For example, satellites in space play a crucial role in monitoring climate change, predicting natural disasters, and managing resources. With lower launch costs, more satellites could be deployed to enhance Earth observation and environmental management. Additionally, the space elevator could pave the way for off-Earth industries that use space-based resources, such as asteroid mining. By extracting resources from space rather than Earth, we could reduce the environmental strain caused by mining and resource extraction on Earth. This could be particularly valuable for rare and precious materials that are becoming increasingly scarce on our planet. Number 8. Safety considerations in building a space elevator. Safety is one of the most critical factors to address when considering the construction of a space elevator. Given its immense scale and the extreme conditions in space, it's essential that engineers and scientists thoroughly assess the risks involved and design systems that ensure both the integrity of the elevator and the safety of those using it. One of the key challenges in ensuring safety is the structural integrity of the tether. The material used for the elevator's cable needs to be incredibly durable to withstand the stresses it will face, including constant tension, high winds, space weather, and the effects of microgravity. And so, here we have reached the end of this video. What are your thoughts about this video? Share with us in the comments below. If you like this video, please give it a thumbs up. Also, do not forget to like, share, and subscribe to our channel. Thanks for watching and see you in the next video.